Hello, everyone. Welcome to the Blue Track at Apisecure 2023. I am proud to present today a second time presenter who we had last year, Yoshiyuki Tabata. He's a software engineer at Hibachi. Welcome. We're happy to have you
Hello.
today.
Thank you for inviting me and
Yeah, this
giving
is
me this opportunity.
for sure. We have you for second time around, so we're very lucky and fortunate to have you speak on your talk today. So without further ado, we'll let Yoshiyuki go ahead and go ahead with your talk.
Okay, so hello everyone, and thank you for attending this session. My name is Yoshiyuki Tabata, and I work at Hitachi. The title of this session is Security Consideration for API Gateway Aggregation. These days, we often hear the word API Gateway Aggregation with several meanings. Here, I treat API Gateway Aggregation as bundling multiple API gateways, proxying API requests to the API gateways, and applying several policies to expose APIs to the outside. In this situation, we need to consider several things, especially for security. I describe the security considerations for API gateway aggregation, and after that, I describe several advanced use cases of API gateway aggregation. The slides of this session are available at SlideShare, so please get them from there if you like. First of all, please let me introduce myself. My name is Yoshiyuki Tabata, and I'm a software engineer at Hitachi. I mainly work as a specialist in API authorization. For example, I consult for API management infrastructure and authentication and authorization systems in the financial, public, social, and industrial fields. And I'm also a contributor to OSS related to authentication, authorization, and API management. For example, I contribute to Keycloak, an identity and access management OSS, and Prescale, an API management OSS. For these OSS, I developed features required for API use cases based on OAuth and OIDC. And other activities, I spoke at events such as API Days, API Specifications Conference, or Security Workshop, and so on. And I wrote some books and web articles about identity and asset management. So let's get started. These are today's content. First, I describe the introduction to API Gateway Aggregation. After that, I introduce security considerations for API Gateway Aggregation. Finally, I describe advanced use cases of API Gateway Aggregation. First, I describe the introduction to API Gateway Aggregation. Imagine there are multiple APIs. Sometimes we may need to apply policies to API for improving security or developer experiences. In this situation, we may require API management, considering the operational aspect. It is because we need repeated work to apply policies to each API individually. However, we don't need luxurious API management, having luxurious analytics features and billing features. But we only need minimum API management, only providing essential features such as API authorization. This is especially true for small start projects. This minimum API management consists of an API gateway and an authorization server, and the authorization server authenticates users and issues tokens based on OAuth 2.0 authorization code grants, and the API gateway authenticates API calls by validating the access token. That's the client application sense. We can build this minimum API management with only two OSs, Keycloak and NGX, for example. Keycloak is the OSS of identity and access management and acts as OAuth 2.0 authorization server. NGX is the OSS of an HTTP server, a reverse proxy server, and it is often used as an API gateway. One of the features of both OSS is the flexible customizability unique to OSS. Here I briefly introduce Keycloak. Keycloak is Identity and Access Management OSS, and Keycloak provides OAuth 2.0 authorization server features and single sign-on features. There are three main features. First, Keycloak provides support for OAuth 2.0, OpenID Connect, TAML, and the latest specifications like financial grade API. Second, Keycloak can connect to existing LDAP or Active Directory servers. Finally, Keycloak can log in with social networks, such as GitHub, Twitter, and Facebook. Let's go back to the main topic. There's a common issue for companies providing multiple services. Imagine there are multiple services. Of course, all services can be handled by one API management system, but there may be cases where multiple API management systems exist in-house together. If members of API development teams are completely separate, there are few advantages in forcing them to use the same API management system, and the advantages do not justify the cost. So the latter case is that of multiple API management systems existing in-house together might be many. So this is a common and not so bad situation. However, recently, use cases for exposing APIs outside the company became popular, such as providing APIs to third-party applications and remote workers. In these use cases, we can publish the internal API. Now, in these use cases, can we publish these internal APIs to them without any changes? Probably we cannot. These existing APIs are developed for improving development efficiency, for example, so there might be low-level security and usability, considering exposure outside the company. So we must improve security. However, we don't want to spend costs that much and don't want to bother existing services or end users of the services. In summary, at a minimum, the following points should be considered when exposing API. First, minimum security, such as API authorization and OAuth top 10. Second, minimum impact on services provided to existing users. Here, we propose API gateway aggregation. That is, to build an API gateway aggregator between clients and API gateways. This solution meets these requirements. Of course, there are other solutions. For example, renewing the API gateways to one large API gateway. This is possible, but the impact on existing services might be more than this solution, because the services API gateways are completely changed. This solution doesn't change the API gateways that existing services use, so it can minimize that kind of impact. Another example, applying policies to each API gateway individually. This is also possible, but we might need a higher operational cost than this solution, because we need to repeat applying policies by the number of API gateways. In this solution, we only need to apply policies once to the API gateway aggregator. From the next slide, we will proceed with the story based on this API gateway aggregation solution. Next, I introduce security considerations for API gateway aggregation. What do you come up with in security considerations? There are many things, but here we consider how to meet requirements with API gateway aggregation, especially focusing on the API authorization perspective. The requirements are following: minimum security and minimum impact on services provided to existing users. At first, we focus on minimum security. There are two viewpoints on minimum security: API authorization and OAuth top 10. Regarding API authorization, we should build an OAuth 2.0 authorization server. The authorization server issues tokens based on OAuth 2.0 authorization code grant, and the API gateway aggregator verifies the access token. It should verify the token's issuer, audience, expiration, and revocation. If the access token is an assertion token, like JSON Web Token or JWT, the API gateway aggregator also should verify its signature. This is also the general API gateway feature, so not so hard to implement, because you may already implement this in each API gateway. Regarding OAuth top 10, we should build WAF, Web Application Firewall. WAF often appears in architectures such as perimeter-based protection and defense in depth. Since this solution also exposes the API to the outside world, we desire WAF, which is highly cost-effective security feature. Next, we focus on the minimum impact on services provided to existing users. To consider the impact on services, we need to consider the issuer of tokens each API gateway uses to authenticate API code. If the issuer is changed, we require at least some API gateway logic changes to deal with its token. So, its logic changes may cause an impact on services. If API gateways deal with the tokens only issued by their dedicated authorization server, we don't need to change the API gateway logic, so the services work with no problem regarding API authorization. However, what if API gateways deal with the tokens issued by the authorization server for external applications? Until here, API gateways have only dealt with access tokens issued by their dedicated authorization server. If we make API gateways deal with access tokens issued by the authorization server for external applications, we need some ingenuity. The first option is to use the same access token as the third-party application sent when the API Gateway aggregator calls the API Gateway's API. If the API Gateway aggregator reuses the access token from the external application sent, the individual API Gateway must deal with access tokens issued by multiple authorization servers, its dedicated authorization server, and one for external applications. We should avoid this situation, which is dealing with the tokens issued by multiple authorization servers, because it extends the surface of possible attacks like IDP mix-up attacks and has impact on services. Specifically speaking, in this situation, the API gateway must judge dynamically which authorization server issued the access token received, because it needs to connect to the authorization server to request the token signing key or to delegate token introspection. At that time, there is a possibility that API, the API gateway may allow illegal requests if the API gateway selects an authorization server under the attacker's control. If the API gateway doesn't need to deal with tokens issued by multiple authorization servers, there is no possibility that the API gateway may allow illegal requests because it connects fixed one authorization server and doesn't need to judge the authorization server dynamically. So we don't recommend this first option. The second option, our recommended option, is to use the different access token as the third-party application sends when the API gateway aggregator calls the API gateway's API. We realize this option by using OAuth 2.0 token exchange, defined by RFC 8693. The API gateway aggregator exchanges the access token with a different access token in each API gateway authorization server. At this time, the issuer of the access token is changed from the authorization server to authorization server for external applications to the dedicated authorization server for each API gateway. Then the API gateway only needs to communicate with its dedicated authorization server, not need to communicate with the authorization server for external applications. Basically, we don't need to change API gateway. Furthermore, we can realize another scenario called token translation. That is, API gateway aggregator exchanges lightweight access tokens with more claimed packed access tokens. A lightweight access token means an assertion-based access token like JOT without privacy information, or a handle-based access token like a random string. We can introduce this token translation scenario in order to protect users' privacy. The authorization server issues a lightweight access token to external applications, and the applications call API with that token. After that, the API gateway aggregator exchanges the lightweight access tokens for a more claimed packed access token in order to API gateway to deal with it as ever. So far, I explained various features, and we can realize this API gateway aggregator only with Keycloak and NGX. Regarding OAuth 2.0 token exchange, Keycloak has that feature, albeit a technology preview. Regarding WAF, we can use Nginx App Protect, a high-performance and high-functioning WAF, and Nginx App Protect can also protect each API individually using OpenAPI specification. Finally, I describe advanced use cases of API aggregation. Token translation, as I described in the previous slide, is also an example of advanced use cases, and here we introduce the other use cases. The first advanced use case is to access highly sensitive data. As API usage flourishes, it's common to see more sensitive data exposed to API, or highly important transactions triggered through API. In that case, the system must support a high security profile like PAPI, Financial Grade API Security Profile. Here I briefly introduce PAPI, Financial Grade API. Financial Grade API PAPI Security Profile requires a high level of security based on OAuth 2.0, used as a protocol for API authorization, and OpenID Connect, OIDC, used as a protocol for single sign-on. PAPI defines secure usage of OAuth 2.0 and OIDC to apply to APIs in any market area. PAPI 1.0 consists of two parts, Part 1 Baseline and Part 2 Advanced. Part 2 Advanced is more high security than Part 1 Baseline, and it doesn't only refer to RFC 6749, the OAuth 2.0 authorization framework, and OpenID Connect Core 1.0, but also refers to many other high security standards, and defines the high levels of security. Now, many countries are moving toward PAPI compliance, especially in the financial area. To support PAPI, the authorization server, the client application, and the resource server all must meet PAPI requirements. This API gateway aggregator built with Keycloak and NGX can support PAPI. Specifically speaking, Keycloak fully supports PAPI authorization server requirements and got certification. And it is not officially announced, but NGX can support PAPI. We can customize NGX in JavaScript or Lua languages flexibly, so we already have verified NGX could support PAPI by customizing it. PAPI resource server requirements are less than other component requirements, so it is not so difficult. Finally, PAPI client. It is a little difficult to implement, but we Hitachi publishes a certified implementation of PAPI client, so you can refer to it and implement it easily. Our solution can cover PAPI use cases like this. The second advanced use case is Zero Trust Network. As the use of APIs progresses, we may incorporate into the system not only our APIs, but also external APIs like third-party SaaS APIs. This situation increases the risk that the system unknowingly incorporates compromised APIs. If you treat the internal network of the system as an implicit trust zone, a domino effect may happen that compromises one component after another. To protect from a domino effect, we should implement a zero-trust network. To implement a zero-trust network, mutual TLS, MTLS, and just validation are essential technologies. In this solution, we realize a zero-trust network by establishing MTLS connections between two NGX and validating access token, which is just in cooperation with Keycloak. Connecting with MTLS can be easily achieved by setting certificates in NGX. So if you deploy NGX as a sidecar for external applications and APIs, for example, you can simply achieve MTLS. And Keycloak provides a token introspection endpoint, so NGX can validate the access token by using that endpoint or validate the JOT access token locally. Regarding access control by using policies, Keycloak also supports policy decision features and policy administration features called authorization service. So NGX can delegate PDP features to Keycloak and focusing on PEP features and improve performance. Furthermore, by integrating Vault, NGX can delegate certificate management to Vault. Specifically, Vault supports real-time certificate issuing requests, and NGX supports the dynamic certificate loading feature. Combining these features can reduce the operational load of certificate management for MTLS connections. There are many other advanced use cases, so if you want to know more, feel free to ask us. For example, for native applications, Keycloak can issue client credentials via the dynamic client registration endpoint. Another example, for browser-based applications, NGX can behave as BFF, backend for frontend, which handles the full authorization flow and manage tokens. These are just a few examples, so please contact us if you have any problems with similar architecture. Okay, so this is the last slide, so and time I left, so I demonstrate uh, token no, this token exchange using the speaker. Assume that this test is the API gateway, API, the authorization server for the external application, and this API gateway realm is the authorization server for individual API gateway. Then first, I This is a resource owner password credentials grant request. It is easy to issue. If you issue tokens in production environment, please use the authorization code grant. And first token issues. This is an access token issued by authorization server for external applications. Let's decode this. The issuer is the test, so it indicates this token issuer is the authorization server for external application. Then let's token token exchange. Assume that this request is from API gateway aggregator. This is a sample of token exchange request. And then API gateway aggregator gets the different access token. Then let's decode this. So you can understand the issuer exchange. This API gateway level is the dedicated authorization server for API gateway. So you can see the issuer exchange, and also the audience is API gateway. So this suppose that this token consumer is the API gateway. Now this is a brief token exchange demonstrate. Okay, so finally, this is today's summary. We propose API gateway aggregation, and it can expose APIs outside the company with minimum security and minimum impact on services provided to existing users. And its underlying technologies are OAuth2, WAF, and token exchange. And it can build with Bclock and CGX. Furthermore, it can support advanced use cases such as PAPI and zero-trust networks. These slides are available at SlideShare, so please get them if you like. That's all. Thank you for listening. We would appreciate your feedback.
Thank you, Yoshiyuki. This was a fantastic presentation, and I really love the demonstration you provided. We had some quick comments from VK Frost, and one of the comments he made was, we have faced challenges with access token and API gateways because of the different scopes and claims for different customers. Can you, a little bit, speaking on the different scopes, I know that's so key to API security. Can you speak a little bit of some of the threats if you don't, modify or change the scopes or even enable the scopes?
You mean we can change or add scopes in the timing of the token exchange?
That's correct. Yeah, with
Mm-hmm.
different customers, there's different requirements, right?
Mm-hmm.
Um, so I'm just curious to know from your perspective and your professional experience if you had any customers that didn't make any modifications.
Maybe if the customer change, the client application can specify the scope for its authentication or authorization request. So it can easily change the scope. And also, maybe the kickoff not support, but uh, the API gateway aggregator can change scope uh, in uh, token exchange timing defined following the RFC host to zero token exchange. Is this answer your question?
Yes, thank you for sure.
Mhm.
And just looking at the chat here, feel free to put questions in the comments while I have Yoshiyuki here. One
Mhm.
question I had regarding third-party apps, what are some ways, outside of the use cases you provided, that companies can use quickly to identify that third-party apps are malicious, right? Because we don't really know what's out there unless we do appropriate testing. So, what are some quick wins that companies can do to easily identify them?
Uh, I can't understand which comment to refer to.
Oh, this is just something I wrote down when looking at your
Mhm.
slides. So basically third party apps, right? So we don't know what we're protecting against with third party apps, and naturally we're always in with different types of IoT services and different types of applications that we're constantly using for the business operations. What are some of your thoughts, before going into making sure that we're secure using the OWASP methodology? What are some quick wins that you can think of to recommend to companies and or entities to help protect against apps that are malicious from the API side?
Mm, mm. Uh, uh, I can I don't I can understand correctly. Maybe the web application is the most secure application, and that's because they can store credentials in the server side. And then, uh, first of all, OAuth 2.0 is three types of client profiles: a web
Hmm.
application, and native application, and browser-based application. Then the web application is the most secured option, and next then native application. But if the native application deployed by the application store, the application might be the public client. So I described the binary, right? If you use this native application, we we should provide something like the dynamic client registration to provide client credentials. That's the security considerations for native apps. And finally, the broad-based application. That is a very uh, uh, the most insecure uh, client profile, but we provide BFF solution backend for front end. And then if you use the broad-based application, you can store tokens in the hub side. So it can become a little better, for security. Uh, and that solution can be uh, accepted for production, I think.
Perfect. Yeah, exactly. That's exactly where I was going with tracking And one question VK Frost had here also in the comments was he thinks API security inventory has been a big challenge. We don't know what we know, right? And keeping track of those APIs are to inventory them, to keep, to constantly see what's popping up. No matter how many solutions you put in place, different operational or developing tracks or places in the company would definitely use them. Is there a way to keep track, or would the API gateways have a configuration to keep track of that inventory? Um, or is there something that you can see or monitor to help with that?
Mm-hmm. Yeah, I understand the API discovery immediately has been challenged, and maybe uh, regarding this solution, this is focusing on the essential features like API authorization. So this solution doesn't don't focusing on covering this uh, kind of things. And yeah, if our customer or requirement, our customer requires this uh, requirement, we consider and we think uh, with this kind of discovery inventory together. In summary, this solution is not focusing on this kind of uh, feature.
Understood. Yeah, it's tough, right? Because I know several different CISOs. When you ask them about, hey, how many APIs do you have in the environment? That's a moving target, right? Sometimes they'll say, hey, I have 12. But in reality, when you do discovery, it's like 25, 30, 40, 50, right? So if there's a way to track it effectively while seeing those that they get decommissioned as well as pop up in the environment, that would be super helpful, right? To help
Mhm.
gauge and to secure those APIs.
Yeah, there
Awesome.
may be some steps of the API gateway API management, and we focusing on the maybe the first one or two steps of the API gateway aggregator. So if this system grows and the API number of the APIs grows, this uh, kind of consideration is needed, I think.
Fantastic. Any last closing thoughts for our viewers here on your specific talk on API security?
Thank you for listening again. And yes, we'd like to consider the API security with the customer and with you also. Please feel free to contact us. Yeah, thank you very much.
Thank you, Yoshiyuki. We appreciate having you here. Hopefully, we'll get you back next year.